In this session, I am going to explain linked list. Before switching into a linked list, I want to explain what are the limitation of the arrays, because there are some major limitation in arrays. We have used the concept of arrays in stacks, queues, and etc. Let us discuss one by one what are the limitation over the arrays. That means why are we are using linked list, or why are we switching to the linked list. Till now we are using array data structure to organize the group of elements that are to be stored individually in the memory. Second, however, array has several advantages and disadvantages which must be known in order to decide the data structure which will be used throughout the program. Let us discuss advantages. Previously I have told. Let us now concentrate on the disadvantages. That means what are the limitation. Array contains the following limitations. What are the limitation? The size of array must be known in advance before using it in the programs. That means when you declare an array, for example, we can take as a stack. If you want to insert an item into a stack, first initially we should know how much item I want to insert. I want to insert whether 5 elements, 50 elements, or 60 elements. In advance only I should declare the size of array. Increase size of the array is a time taking process. It is almost impossible to expand the size of array at run time. That means increasing in the size of array is a time taking process. Means, for example, now I have taken example of stack. There I want to insert 5 elements. Well and good, I have declared 5 elements and I have inserted. Next I want to insert a sixth element into a stack. Then I should redeclare the array once again. That means the array size should be increased by 1. That means for a single one also I should once again come and I should redeclare. For that reason we are telling increasing size of the array is a time taking process. And next is, it is almost impossible to expand the size of array at runtime. During runtime I cannot increase or decrease the size of the array. That means the array size is 5. Initially I have declared. I cannot increase it into a 6, or I cannot decrease it to a 4. This is the main disadvantage of the arrays. Next, all the elements in the array need to be contiguous, stored in the memory. Inserting any element in the array needs shifting of all its predecessors. That means elements cannot be inserted in between the items. For example, all the elements in the array need to be contiguous. Here it is in a statement. Here I am showing. Now, for example, I want to insert this stored item in between elements and in. It is not possible in the array because it is not supporting, because it is a contiguous one. For that reason it is very difficult to insert an element in between in a array. Inserting any elements in array need shifting of all its predecessors. That means I should shift these elements which is I want to insert this stored in between elements and in. This is the main disadvantages. For this reason we are shifting a new concept called as a linked list. Now, what is linked list? In the abbreviation only it is there. Linked list. That means a list can be linked with another list. That is called as linked list. For example, now sequence and of. Here two words are there. These two words are have linked. The best example I am giving is an a railway. In a railway department, you can see train. The train here UA is an engine. Linked list is a sequence. You assume that these are coaches. This engine is linked with this linked word via a cable. You can see in a coach. In between coaches there is a cable, that is vacuum tube. Same thing, this in linked list also it is done same thing. In upcoming slides I am going to explain how it is linked. Linked list is a sequence of links which contains an items. Each link contains a connection of another link, as I told. That means in each link there is an item. Item means the things which I want to insert. Then link means which is connecting. That means it will store the address of the another variable. That means next coach address of that elements. In next we are telling that there is a word, technical word called as node. For the time being I am taking an example of a coach. Linked list is the second most used data structure after arrays. Following are the important terms to understand the concept of linked list. Link. What is link? Each link of a linked list can store a data called an element. That means here you can store an element. Next, there is a word next. That means what is next? Each link of a linked list contains a link of the next link called as next. That means it is a link connecting here as previously I told coach. This is link is a coach and next is acting like a vacuum tube. This vacuum tube is connecting to the next coach. That means each link of link list contains a link of the next linked list. Then what is linked list? A linked list contains the connection link to the first link called as first. Now you can see here how it is defined. A linked list data structure includes a series of connected nodes. Here you can see. See, it is similarly looking like a railway coaches. Here, each node stores the data and address of the next node. For example, here you can see coach 1, coach 2 and coach 3. The first coach is called as an head and last coach is called as an null. In between, there is a connection, that is arrow marks. This next is nothing but which stores the address of the next coach, and similarly this will stores the address of the next node. Data is nothing but items which are I am inserting. Here you can see this is called as add and this is a data and this is a link. The first one it is named as an add and last one it is named as an tail, because at tail the last link or next address is will be always null. These two, data and link, both are called as node. Node is what? Node is equals data plus link. That means link is nothing but which stores the next variable. Node. We have to start somewhere, so we give the address of the first node as a special name called as add. That means the node which is the first one is called as an ed. Because for identification, I am naming first node as an ed. Also, the last node in the linked list can be identified because it is the next portion of the null. You might have played the game Treasury Hunt, where each clue includes the information about the next clue. That is how the linked list operates. That means all are familiar with this game Treasury, and there we are going to catch some monies, all those things. While catching, we are getting an hint of the next what I should do. Same thing it is done here. Why list? Users of the linked list. This list is not required to be contiguous present in the memory. It is not necessary to be continue. The node can reside anywhere in the memory and linked together to make a list. This achieves optimized utilization of space. That means the meaning is very simple. That means I can insert any element in between the list and I can add or I can delete anywhere. List size is limited to the memory size and does not need to be declared in advance. There is no necessary to declare in advance as we are doing in arrays. Empty node can not be presented in the linked list. We can store value of primitive types or objects in the single linked list. Linked list is the data structure which can over all the limitation of arrays. Using linked list useful because as told that the main disadvantage or limitations of the arrays are overcome by the linked list. What is that one? It allocates the memory dynamically. That means during the runtime, the memory is allocated. All the nodes of the linked list are non-contiguous, stored in the memory and linked together with the help of pointers. That means in arrays what happens? This is a contiguous memory. In array it should be like this only. What happens in the linked list? You assume that here it is in a space and here it is also space and here it is also space and here it is also space. All these space are connected using with the help of pointers. That means the space cannot be or should not be contiguous. Here non-contiguous also memory are taken. Sizing is no longer a problem since we do not need defined its size at the time of declaration. That means as we told that for arrays it should be predefined. Here there is no necessary to define the size. For example, in a stack I have told I have taken a declared for 5 in arrays. If I try to insert a sixth element, I should move and increase the array size and I should put another item. That problem is resolved in linked list. There is no necessary to predefine. I can insert anywhere in the linked list. List grows as per the program demands and limited to the available memory space. That means whole space can be put in the memory. Now what is node? I have told that here there are two parts. This is elements and this is link parts. You can see here data and pointer. What is data? Data is nothing but an item to be stored. What is pointer? Pointing to the next node of the element or next node. That means here A and here you can see the linking area. This linking area contains the address of the what B node. Similarly, C contains the here B contains this part contains C's address. Similarly, this one, and last it is contained with null value. When it reaches null value, it is assumed that the null value is an end of the node. A node in a linked list holds the data value and the pointer which points to the location of next node in the linked list. These are the nodes which are connected. In the picture above, we have linked list containing 4 nodes. Each nodes has some data A, B, C and D and a pointer which stores the location of the next node, as I have explained. You must be wondering why we need to store the location of the next node. Yes, that is the point. Here, well, because the memory location allocated to these nodes are not contiguous. Hence, each node should know where the next node is stored. For that reason, we are using, because here A and B is there. It is A may be anywhere and B may be anywhere, but these are interlinked. For example, you assume that A is in Karnataka and B is in Tamil Nadu and C is in Andhra Pradesh. All these are interlinked with an address value. What happens in arrays? If you take in arrays, ABC should be in one location, that means one memory, that is contiguous, that is in Karnataka only. This is overcome there. Next, as the node is combination of multiple information, hence we will be defining structure for node, which will have variable to store data and another variable to store the pointer. In C language, we create a structure using the struct word. Here I am writing the C function of the node. Struct node int data. Data is nothing but to store the element, and next is an variable which is used to store the address value, and for that reason I am declaring struct node. This concept is called as what in previous I have explained, that is self-referential structure. That means where this and this are same. That means struct node. Node is nothing but the structure name, and the variable which is I am using, this is also a structure, that is data type is also same. For this we called as a self-referential structure. After that, what I am doing, struct node head, I am taking another variable, that is the first variable, and initially I am using assigning the null value to the head. Where linked list are used? What are the applications? Let us begin. Dynamic memory allocation implemented in stacks and queues. I have explained stacks and queues using arrays. Now this concept is also used in stacks and queues in undo functionality of software. That means software also it has been used as tables and graphs, etc. Thank you.